right, we are covering absolute value inequalities. There are two different cases. The first case, absolute value of x is greater than or equal to 5. What happens with that is we turn it into an OR. The acronym GOAL helps us. So if it's greater than, it becomes an OR compound inequality. And then the case 2, if it's less than, it's an AND inequality. So we switch it around and we make it an AND inequality and we solve. So what does this mean? Absolute value inequalities are really compound inequalities. We have to do the transformation. So less than is AND, greater than is OR. I use GOAL to help me remember. Okay? So greater than is OR, and is less than. Okay? Steps to solve. 1, isolate the value, absolute value expression. Step 2, create two cases. It says the KISS method, so keep it, switch it, and then to set up the two cases. Step 3, solve both inequalities. And then 4, graph and write your answer in interval notation. We have lots of practice with that. All right, so let's look at our first two examples here. We're going to kind of keep it basic. Here's my goal. So x, the absolute value of x is less than 7. Okay? Less than down here means this is going to be an AND. So I'm going to take what my value is. I'm going to make it the opposite. I'm going to make it an AND inequality. So go ahead and write that down. That's done. My x is positive, it's alone, it's in the middle, we're good to go. So to graph this, I'm going to do an open dot at -7. It is not marked on my graph, so I need to mark it. An open dot at +7. And means we shade in the middle. So all these values in here make this a true statement. With my interval notation, I move left to right on my graph. So I'm coming and I stop at -7. It's an open dot, so that's parentheses. I keep going, I stop at +7, open dot, which is parentheses. Number 2, absolute value of x is greater than or equal to 4. Greater than becomes an OR. All right, remember our OR, outwards. So we have our -4. So we have to flip this. So x is less than or equal to -4. Or x is greater than or equal to +4. This goal helps us out. So greater than is OR, less than, and AND. Okay, so graphing this is all done. X is positive, it's by itself, it's on the left. We have a closed dot at -4. It is being shaded to the left. So I'm going to shade this to the left. A closed dot at +4, and it's greater than, so I'm shading to the right. My interval notation, I'm moving left to right on the graph. So I'm coming in from a -infinity. We know that -infinity is always a parentheses. I stop at -4. Closed dot means bracket. We write the word OR in between. I keep moving down my number line. I stop at +4. Closed dot means bracket, and it goes to infinity. So those are the first two. We've got 2 more left in this video. Let me scroll this up a little bit more. Okay. I'm going to keep my goal up there just so that we remember. Greater than is OR, and is less than. All right, number 3. This is greater than. Greater than means it becomes an OR. So I take what's inside here, I reverse the sign, and make it negative. I do that again, but I keep the sign the same and the value the same. So OR x minus 1 is greater than 6. So to solve this, I'm gonna throw my line here. Solving it two different, I'm gonna add 1. X is less than -5. Same procedure over here. X is greater than 7. Those guys cancel out. So my or is in the middle. Coming over to my graph at -5, we're right here. Write that on the graph because I don't have it labeled. It's an open nut because there's no line underneath, and I'm shading to the left. So that's the way it's pointed. Half of the graphing is done. We're going to do x is greater than 7 now. Open nut at 7. It's not labeled, so I need to mark it. And I'm shading to the right. It's greater than. All the values that are greater than 7 are over to the right. One final step, interval notation. I'm coming across the graph. I'm coming in from -infinity. I'm stopping at -5. Open dot means parentheses. I write or. I keep going. I stop at 7. Open dot is parentheses again, and I go off to infinity. So we're reading our graph left to right. That helps us write our interval notation. All right. Last one on this video. So this is greater than. This one's a less than. It's really important that we can read our signs because that tells us what compound inequality we're changing to. So a less than becomes an and. So I take the opposite of this number, -7, and I put it on the other side, and I smush what's inside the absolute value. So it becomes an and. So less than is an and inequality. You take the opposite of the number over here, put it here, smush it between what's in the absolute value, and then finish it with what is written. Solving this, what I do to the middle, I have to do to the sides. So -9 is less than or equal to x, which is less than or equal to 5. X is by itself, it's in the middle, I can graph this. So on this graph I'm looking at -9. I have a line underneath here, so that's a closed dot. So at -9 I have a closed dot. At 5, another closed dot. My x is in the middle, so I shade in the middle. Last step of this, interval notation. I come across the graph, I stop at -9, closed dot is a bracket, I keep going, I stop at 5, closed dot is a bracket. So that is part 1 of solving absolute value inequalities. Tune in next time for part 2.